We're going to continue looking at using laws of exponents to simplify expressions. And we're just using the laws that we've been learning about. Yesterday we saw that when you deal with rational exponents, which means that, earbuds out please, which means that the exponents are fractions, it doesn't change the rules, but you have to remember if you're adding or subtracting fractions, you need a common denominator. So that's something that we're going to have to be aware of. Peyton, earbuds out, please. Thank you. Question A. You're multiplying powers with the same base. The law says that you add the exponents and keep the base the same. So that's what we do. We'll have x to the 1/2 plus 7/2. And in this case, we have a common denominator. So we can add the top numbers together. And remember, once you have a common denominator, you're either adding or subtracting the top numbers, but the denominator stays the same. Brock, your earbud. So that gives us x to the 8/2. You add the 1 and the 7 together, denominator stays the same. 8 divided by 2 is 4, so it becomes x to the 4th. There's the answer. Now with question B, we'll do this in 2 steps. The first step will be multiplying the coefficients. That first part is 3m to the 4th. The second part is just m to the 1/4, but it's like there's a coefficient of 1 in front of the m. There is 1m to the power 1/4 there. So you're going to multiply the coefficients first. 3 times 1 will give you 3. And then when you multiply the m's together, you have to add the exponents. And the 4 I write as 4 over 1. I make it a fraction because I have to add it to a fraction. The fraction is 1 over 4. And to add fractions, we need a common denominator. And our common denominator there will be 4. The second fraction already has that denominator. The first one, though, doesn't. The denominator of 1 needs to be multiplied by 4. And so we need to multiply the top by 4 as well. And 4 times 4 is 16. 16 over 4 is 4. It's the same as 4 or 4 over 1. But we need a common denominator so we can add the fractions together. And when you do that, you add the top numbers, denominator stays the same. So it's 3m to the power 17 over 4. Question C. I would work inside the square brackets first. You're multiplying powers with the same base. The law says you add the exponents and keep the base the same. So it'll be x to the 1.5 plus 2.5 to the power 0.5. 1.5 plus 2.5, you can add those together. You'll get 4 raised to the power 0.5. Brooklyn, what do you do to the exponents now? You multiply them. That's right. Whenever one exponent's raised to another, you multiply the exponents and the base stays the same. 4 times 0.5 will give you 2. There's the final simplified answer. Okay, question D. I would simplify inside the big brackets. All right. Now you cannot divide 5 by 20. However, you can consider that to be a fraction 5 over 20, which can be reduced. You can divide both the 5 and the 20 by 5. And that'll leave you with a 1 on top and a 4 on the bottom. Right? The coefficients are 5 on top, 20 on the bottom, so you can write that as a separate fraction, 5 over 20. And that can be reduced by dividing top and bottom by 5, and so you'll get 1 over 4. But then you can divide the x's, and you're dividing powers with the same base, so you subtract the exponents. That x on the bottom would be x to the power 1. So when you subtract the 3 minus 1, you'll get 2. And that x squared is on the top. And that's raised to the power 1/2. So that's where we are right now. Okay? And now we can raise everything inside the bracket to the power 1/2, which is outside. So when we deal with the x squared to the power 1/2, we multiply the exponents. 2 times 1/2 will just be 1, so you'll get x to the 1, which is just x. And on the bottom, you've got 4 to the power 1/2. You have to raise everything inside the bracket to the power 1/2 that's outside. And Keen, what did we see yesterday? What does power 1/2 mean? Don't give me the stink eye. What does power 1/2 mean? How do we do 4 to the power 1/2? Jan? That's right. The denominator tells you what root it is. Denominator of 2 means square root. The top number also tells you what power it's raised to, but raising something to the power 1 changes nothing. So this is the same thing as x over the square root of 4 or x over 2, which incidentally would be the same thing as 1/2 x. It's the same thing, and here's the reason why. If you make that x a fraction by going x over 1, and you multiply top times top, bottom times bottom, you will get x over 2. They mean the same thing. Question E. Allie, what do we do to the exponents here? You multiply them, that's right, and the bases stay the same. So you're going to have x to the 2 over 3 times 3, which is 3 over 1. And then for the y part, you're going to have x to the 4 over 3 times 3 over 1 as well. Now you can multiply top times top, bottom times bottom, and then simplify. So 2/3 times 3 over 1 would be 2 times 3, which is 6 over 3. On the bottom, 3 times 1 is 3. So you'll have 6 divided by 3, which is just 2. But you see, you could get that by canceling the 3's. When you're multiplying fractions, if you have numbers on the top and the bottom, whether they're directly on top of each other or diagonally across from each other, you can reduce them. You can divide them both by the same value. In this case, we're dividing those both by 3, and that's another way you're going to get the x squared, because you're left with 2 times 1 over 1 times 1. So same thing with the 4/3 times 3 over 1. The 3's would cancel, and you're left with 4 times 1 over 1 times 1, which is just 4. Either way, there's the answer. So you can multiply first, simplify after, or simplify first and then multiply. Okay. So same thing with number 2, simplify each expression. You're asked to state them using positive exponents only. So question A, multiplying powers with the same base. The law says you add the exponents and keep the base the same. In this case, one of the exponents is a fraction, so we're going to have to get a common denominator. I also made the -2 a fraction by putting it over 1. So you need to add -2 over 1 plus 5/2. And to do that, we need a common denominator, which would be 2. The common denominator is 2. The second fraction already has that denominator, so it's not going to change. But the first one, you're going to have to multiply by 2 on the top and bottom in order to get a denominator of 2. -2 over 1 is the same as -4 over 2. And now we can add the fractions together. -4 plus 5 is +1, but remember, you always keep the same denominator. When you're adding and subtracting fractions, once you have your common denominator, that doesn't change. It's like you have -4 of something and you add 5 of those same things, and that leaves you with one of those things, and those things would be halves. Question B. Everything inside the brackets raised to the power 1/3. So that includes the -8 as well as the x to the -6. And when you have one exponent raised to another, you multiply the exponents and keep the base the same. That's what we have learned. So it's -6 over 1 times 1 over 3. But before we deal with that, we have -8 to the power 1/3. What does power 1/3 mean, Keen? Okay, well, the denominator is 3. Now that Princess helped you? Yeah, sure. The cube root. The cube root of negative 8 to the power 1. That's what that means. Now, when you multiply the exponents on the x, it'll be negative 6 on top over 3 on the bottom, which is negative 2. You also could have gotten that by canceling. 3 goes into itself once and into negative 6 negative 2 times. So it's negative 2 times 1 over 1 times 1. Either way, you get an exponent of negative 2 on the x. And the cube root of negative 8 does exist. It is negative 2. Cube root is asking what number times itself 3 times will give you negative 8. Negative 2 times negative 2 times negative 2 does give us negative 8. But we can also use our calculator. Most calculators allow you to take the cube root if you know how to use it. The cube root of negative 8, again, is negative 2. So this is negative 2 times x to the negative 2. Are we done, Riley? Why not? How do we do that? What do you mean switch it around? Right. You move it to the bottom. Only the x moves to the bottom, right? There are no brackets around the negative 2x, which means that exponent negative 2 applies only to the x, not the negative 2 coefficient. The negative 2 will stay on top. Only the x moves to the bottom. We said this many times. A negative coefficient is not a problem. There's nothing you can do to change that. Only negative exponents do you need to worry about. You must make negative exponents positive. So there's the final answer. Okay? Question C. I would simplify the top and the bottom first. In each case, we have one exponent raised to another. We know that we multiply the exponents and keep the base the same. So for the x cubed to the 1/2, you're going to multiply 3, which is 3 over 1 times 1 over 2. And then on the bottom, excuse me, you're going to multiply the 5 over 2 times 1 over 5. That's what we do when we have one exponent raised to another. We multiply the exponents. Now, for the top, we cannot cancel anything, so we'll just multiply top times top, bottom times bottom. That'll give us x to the 3 over 2. But on the bottom, we can divide top and bottom by 5, which would leave us with 1s there. So we're actually multiplying 1 times 1 on top over 2 times 1 on the bottom. That'll be y to the power 1/2. So can we divide these two by subtracting the exponents? Oh, I'm sorry. That should have been an x, shouldn't it have been? I'm sorry about that. Now we can divide them by subtracting the exponents because the bases are the same. So it'll be x to the 3/2 minus 1/2. So that one already has a common denominator. We don't have to find it. It's already there. 3 take away 1 on top is 2, and the denominator doesn't change. 2 over 2 is 1, so it's x to the 1, or just x. There's the final simplified answer. It's just x. Okay, question D. The coefficient in front of the x to the 1/4 is 1. So we've got 1 on top and 16 on the bottom. There's nothing we can do with that right now. The 1 will stay on top, the 16 will stay on the bottom. But we can divide the x's. We're dividing powers with the same base, so we subtract the exponents and keep the base the same. It'll be 1/4 take away 3/4. Let me try and draw that a little better. And when you subtract 1/4, take away 3/4, it'll be negative 2/4, which is the same as negative 1/2 over 16 on the bottom, and that's all raised to the power positive 1/2. So on top, we have one exponent raised to another. What do we do to those exponents, Emil? Multiply. It's going to be a negative times a positive, which is a negative, and you multiply by going top times top, bottom times bottom. 1 times 1 on top is 1, 2 times 2 on the bottom is 4. But we also have to make sure that we take the denominator of 16 to the power 1/2 as well. Everything inside the bracket is raised to the power 1/2. And Stanley, what's 16 to the 1/2 equal? Can you help him, Peyton? Just because you don't like him and you're not going to help him? Okay. Well, we've talked about what does power 1/2 mean? Do you remember, Peyton, what the power 1/2 means? Don't remember? Okay. Sal? Means square root. Remember, when you have a rational exponent, the denominator tells you what root it is. Remember that now? Yeah. So that's the square root of 16, which is 4. The other thing I would do at the same time, you got to move the x down to the bottom because we must make the exponent positive. So it'll become 1 over, again, the square root of 16 is 4. And when you move the x down to the bottom, the exponent sign becomes positive 1/4 instead of negative. All right, looking at question E. What we have here is we have two things multiplied together, and in math we call those factors. Factors are things that are multiplied together. So the first factor would be that expression I've just underlined in black, and the second expression, that's the second factor there. Can anyone see something that we can do that is going to really make this quite a bit easier? Yes, Peyton? Yeah. It's all to the power 0. Anything to the power 0 we know equals 1. So really we're going to have 1 times that second bracket, and that second bracket has 1 power raised to another. We know that you're going to multiply the exponents and keep the base the same. So it'll be 1 over 3 times 6, which is 6 over 1. And again, if we want, we can simplify that a little bit first by dividing top and bottom by 3. That'll leave you with 1 on the bottom and a 2 up there. And so that becomes 1 times 2 over 1 times 1, which is just 2. If you would have multiplied, you would have got 6 over 3, and 6 divided by 3 is also 2. So whether or not you have the 1 in front of the x squared doesn't matter. Don't need it, but if you put it there, it's not wrong. But yeah, by recognizing that the first factor for part E is all going to be 1 because it's all raised to the power 0, cuts down on the work that you have to do. So it says evaluate without using a calculator, and what that means, just don't put the expression in your calculator and get an answer, because you can. And you could use that for a check to make sure that your answer is correct. But just to show you, 5 to the power negative 2 divided by 125 to the power 1 over 3. You can put this in your calculator, and your calculator will spit out an answer, 0.08. And on my calculator, I can turn that to a fraction by going math, enter, enter, 1 over 125. So that's what the answer is. But you need to know how to do this by showing your work. But you can definitely use a calculator to check. So 5 to the negative 2, we can't evaluate that. We have to make the exponent positive, which means it's going to have to move to the bottom. The one on the bottom has a positive exponent, so it's not going to move. So I'll have 1 on top. On the bottom, I'm going to have 2 different factors, 2 different parts that are multiplied together. The first being 125 to the power 1/3, which means the cube root of 125. And then the 5 to the negative 2 will move to the bottom, and you're going to multiply them by 5 squared. The cube root of 125 is actually 5. And you can do that on your calculator as well. Right? So you're going to get 5 times 5 squared, which is 25. And on the bottom, 5 times 25 is 125. That's the answer that the calculator gave us. So you can use the calculator to check your answers. That is the answer we got when we put the original expression in there. Question B, 9 to the 3 halves over 27 squared. Both exponents are positive, so you don't need to worry about moving anything. Kenzie, do you know how we would evaluate 9 to the 3 halves? Well, remember, you got a rational exponent, a numerator and a denominator. Do you remember what the denominator tells you? It tells you what root it is. Denominator is 2, which means that's square root. And the top number, the 3, means that it's raised to the power 3. So this is the same thing as the square root of 9 cubed divided by 27 squared, which we can find out what that is on our calculator, 729. And now we just have to simplify the top. The square root of 9 is 3, and 3 cubed is 27. And I think these are both divisible by, actually they're both divisible by 27. Because if you divide 729 by 27, you're going to get 27, right? We got the 729 by multiplying 27 by itself. So I can reduce this by dividing top and bottom by 27, and that'll leave us with 1 over 27. There's the final simplified answer. Now again, I could have put this in my calculator at the start. 9 to the power 3 over 2. And that's divided by 27 squared. It gives me that decimal. Well, the answer I got was 1 over 27. If I put that in, I get exactly the same decimal. So I'm just using the calculator to check. The answer we got is equivalent to what we started with. Question C. Right now, the bases are not the same. We have 2 ways we can do this. We can make the bases the same and do it that way, or we can just evaluate each part separately and then multiply the answers together. Because 8 to the power 2/3, we can write that as a radical. Okay? We can write that as a radical. Liam, do you remember how? What is 8 to the 2/3 written as a radical? Declan, can you help him? Jan, can you help him? Pardon? What is 8 to the 2/3 as a radical? As with a root.
So it's 8 squared is a cubic root of 8 squared.
That's right. The denominator tells you what root it is. Denominator 3 means third root or cube root. The top number tells you what power it's raised to every single time. This isn't the first time we've seen this. They're done the same way every single time. So Cherry, then what does 16 to the power 3 have? What does that look like as a radical? Say again. Square root of, what's the rest of it? Anything else? That's right. It's the same thing every time. When you have a rational exponent, that means you have a numerator and denominator, top and a bottom. The bottom tells you what root it is. Top number tells you what power it's raised to. The cube root of 8 is 2, and 2 squared is 4. And that's going to be multiplied this by the square root of 16, which is 4, and 4 cubed is 64. And then if you multiply those together, you will get 256 as the answer. And you know, it doesn't matter what order you do these, meaning that you could square the 8 first and take the cube root second. You could cube the 16 first and take the square root second. You're just going to have some bigger numbers to work with initially, but you would get the same answer. You're probably going to use your calculator anyways, right? And you can also use your calculator to check. 8 to the power 2 over 3 times 16 to the power 3 over 2. 256. Right, that's the answer we got. So you can use your calculator to check your answers on these. Question D. Brock, what do we do to these exponents? That's right, just multiply. And the base stays the same. So it'll be power negative 2 over 1 times negative 5 over 2. And what you can do is you can divide top and bottom by 2 and get rid of those. And so we are left with 3 to the power negative 1 times negative 5 is positive 5 over 1 times 1. If you multiplied first, it would be negative or positive 10 over 2, which still gives you 5. And 3 to the 5th, I think that's 343. 243. So there's the answer. And again, you can do this on your calculator to check. If you go, I'll need brackets here because I've got 3 to the power negative 2 inside the brackets, and that's raised to the power negative 5 over 2. Negative 5 divided by 2. It gives you the answer, 243. That's the answer we got. So you can definitely use your calculators to check your answers. Stanley, what do we do for the exponents in this next one? Multiply, because you got one exponent raised to another. So it's 125 to the power negative 1/3 times 2, which is 2 over 1. Nothing can cancel here. So we're going to multiply top times top. Negative 1 times 2 is negative 2 over bottom times bottom. 3 times 1 is 3. What should we do next, Emery? What do you think? That's right. You got to make the exponent positive by moving it from top to bottom. Remember, this is the same as 1 times 125 to the negative 2/3. So the 1 stays on top. The 125 must move to the bottom. And when you do that, the exponent sign changes. So now we've got positive 2/3 as an exponent on top. Cheney, how do we find out what 125 to the 2/3 is? Can we write that as a radical? Cheney. I'm sorry, Chloe. I meant to say Chloe. I apologize. No, that was my fault. I asked the wrong person, who's not even here. That's why she didn't answer. Sure. What do we do with 125 to the power 2/3? How do we figure out what that equals? That's right. It means the cube root of 125 to the power 2 or squared. The cube root of 125 is 5, and 5 squared is 25. And again, you'd probably use your calculator to do that, but that's what you're going to get. And we can check. I have to use brackets here because I got to have the 125 to the power negative 1 over 3 inside the brackets. And that's raised to the power 2 outside. it gives it to us as a decimal. And if your calculator will not turn your decimals to fractions, that's fine. Take the answer we got, which is 1 over 25, write that as a decimal. 1 divided by 25 is 0.04. Same decimal as what the calculator spit out as the answer. So we know our answer is correct. Okay? Evaluate using a calculator. Give results to 4 decimal places if necessary. We are going to use the laws of exponents first, though, and then we'll use the calculator to get the answer to 4 decimal places if necessary. But we will use the laws of exponents first in order to simplify. So what do you do for the first one, Peyton? Yes. One exponent raised to another, we multiply the exponents and keep the base the same. So I think that's negative 3.6. 1.2 times 3. Yeah, I didn't put negative 3, so negative 3.6. So if we want to find out what that is to 4 decimal places, we first need to make the negative exponent positive. And how do we do that, Jensen? But there's nothing on the bottom. So we got 1 here, and what goes to the bottom? And what happens to the exponent sign now? Yeah. So it's 1 over 7 to the power 3.6. So now we'll get the calculator out to find out what that is. And we're asked to write them as decimals to 4 decimal places. Now my calculator spits it out as scientific notation. 9.0708, that e to the negative 4 means times 10 to the negative 4. To write that in expanded form, we take the 9.0708 and we move the decimal 4 spots to the left. And it's a very small number, a decimal less than 1. It's still positive. That e to the e negative 4 means that the decimal moves 4 spots to the left. It doesn't mean the answer is negative. That is scientific notation. So if you're going to move the decimal 4 spots to the left, you're going to have to add 3 zeros in front. So it's 0.0009 rounded to 4 decimal places. And I'll use approximately equals. Okay, that's what it means. Calculator just puts it in scientific notation. And the reason the last digit is a 9 is because when you look at this, after the 9 is a 0. Remember when you're rounding, if the number to the right of the last digit is 5 or greater, you round up. If it's less than 5, you round down, which means it stays the same. So that's why we have a 9 at the end. Let's use the laws of exponents to simplify this next one. Chloe, what are we going to do to the exponents? And what? Yep. Because we're going to add them. That's what I was looking for. You're right about putting the 3 over 1, but now you have to add the exponents and the base stays the same. I know that's what you were doing, but we need to make sure that we talk about the fact that we're adding the exponents and keep the base the same. And then, yes, absolutely, we need a common denominator, which will be 2 in this case. This denominator of 1 under the 3 needs to be multiplied by 2, so we need to multiply the top by 2 as well. So you'll get 6 over 2 plus 3 over 2. Olivia, what's 6 over 2 plus 3 over 2 become? Pardon? 9 over 2. And what does power 9 over 2 mean? Yeah, it means the square root of 4 to the power 9. The square root of 4 is 2, And 2 to the 9th, I think, is 512. Just check that. 2 to the power 9. Yep, 512. It's 2 times itself 9 times. Question C. Stanley, what do we do to the exponents there? Multiply. So I would write the 3 as 3 over 1 times 2 over 3. And you can multiply and get 6 over 3, and 6 divided by 3 is 2. Or you can cancel the 3's, divide top and bottom by 3, then those become 1's. And on top it's 1 times 2 over 1 times 1. 2 over 1 is still 2. So no matter which way you do it, you're going to get 7 squared, which is 49. Don't have to use the calculator to do that. But again, you could use the calculator to check it. 7 squared times, oh, I'm sorry, that's completely wrong. I need to use brackets here and go 7 to the power 3 to the power 2 over 3. You get the right answer, or the same answer that we got, so our answer is correct. Question D. You cannot divide the top and the bottom because the bases are not the same, right? You cannot say, well, I'm going to divide 6 divided by 3 and get 2. Can't do that because those are bases with different exponents. They're different bases with different exponents, so therefore we cannot use our laws of exponents to simplify inside the bracket, but we do have powers inside the bracket raised to a power outside, and we know that when that happens, you multiply the exponents and the base stays the same, so that's what we're going to do. We're going to have 6 to the 2 over 1 times 1 over 3 on top, and on the bottom it'll be 3 to the power 3 over 1 times 1 over 3. So the 6 will be to the power 2 over 3, and on the bottom the 3 will be to the power 1, because you're actually going to get 3 over 3. Or the 3's cancel and you still have 1 over 1, which is 1. And now we're going to have to use our calculator to get our answer here, but first, 6 to the power 2/3. What does that mean, Brooklyn? If I want to write it as a radical, what would it look like? Get your earbuds out. What does 6 to the 2/3 become? If I write it as a radical. Okay. Brooklyn Lorenz, can you help her? Yes. Denominator tells you what root it is. Top number tells you what power it's raised to. So, we'll use our calculator. In this case, we're going to have to write it as a decimal, round it to 4 decimal places. First, the cube root of 6 squared is that decimal. That's then divided by 3. And rounding it to 4 decimal places, it'll be 1.1006. The fourth digit after the decimal is a 6, and the digit to the right of that is a 4. Because it's less than 5, the 6 stays the same. 1.1006 approximately equal to, because we rounded it. Question E. The bases inside the square brackets are not the same. Right? The top has a base of positive 3, the bottom has a base of negative 3. So we just can't subtract the exponents and keep the base the same because right now the bases are not the same. Okay? There is a way that we could make the bases the same, but that goes a little bit beyond the outcomes of this course. So I'm going to go next to raising everything inside the bracket to the power 1/2, which is outside. And so when in this case, you're going to multiply those exponents together. 2 over 1 times 1 over 2. And on the bottom, it's negative 3 to the power 4 over 1 times 1 over 2. So for the top part, the 2's will cancel, or you can multiply and get 2 over 2. Either way, it's going to be 3 to the 1, which is just 3. And on the bottom, when you multiply the exponents, you're going to get 4 over 2, which is 2. So on top, we'll get 3. On the bottom, when you square negative 3, you're squaring both the negative and the 3. That gives you positive 9. And now this can be reduced by dividing top and bottom by 3. There's our simplified answer. And you could put that original expression in your calculator. You would get 0.3 repeating, which is what 1/3 is. So I'm going to have to use a couple different parts of brackets here. So I've got 3 squared on top divided by, I'm going to have to go negative 3 to the power 4. And I put the negative 3 in brackets. Close that bracket. And now everything is raised to the power 1 over 2. And we should get 0.3 repeating because that's what 1/3 is as a decimal. And we do. So it checks. So you can always use your calculators to check these. As long as the bases are numbers, you can use your calculator to check. If the bases are variables, you cannot. All right, number 5 on the next page. The growth of 5,000 bacterium cells in a lab can be modeled using that expression. N is the number of bacteria after H hours. We saw an example like this yesterday. What does the value 1.5 in the expression tell you? So as we said yesterday, it means that the number of bacterium, or we can just say the number is increasing by 1.5 times every so many hours. We don't know yet what those hours are. Every so many hours. That's what the base means. The base tells you what the multiplication factor is. We saw some yesterday where the base was 2 because something was doubling every so many hours or days or weeks, whatever the case was. Part B says how many bacteria were there after 40 hours. So this would be found by using the equation and letting H equal 40. And because the number under the H is also 40, 40 divided by 40 is 1. So it's going to just be 5,000 times 1.5 to the 1, or times 1.5, which is 7,500. This also tells us that the number of hours where it takes for the number to increase by a factor of 1.5 is 40 hours. Okay, the number at the bottom tells us the time it takes for the base to happen. The base is 1.5, so the number of bacteria is being increased by a factor of 1.5 every 40 hours. Part C, how many more bacteria are there after 3 hours? So we have to find the number after 3 hours and then compare that to what we started with. We started with 5,000. So in this case, H, the number of hours, is 3. And I showed you yesterday, most calculators will allow you to put this entire expression in your calculator all in one step. So it's 5,000 times 1.5 to the power 3 over 40. 5154. If I round it to the nearest bacteria, that's what I would write, 5154 approximately. Again, the question wants to know how many more bacteria were there. So I'd have to subtract 5,000, which is the number I started with, from what I ended up with. So that's approximately 154 more bacteria. And what does H equals 0 indicate? Well, that will indicate that the experiment has just started. No time has gone by. So this would be at the beginning. No time has gone by. And we saw an example yesterday, and there was also a question like that on the quiz, where you can have a negative value of H. If we wanted to know how many bacteria there were, say 10 hours ago, then you'd let H equal negative 10, and you'd get it that way. Okay. So that page there, page 45 is your homework, and you're going to hand this one in. There's only, what, 6 questions there? 8. So you need to show all your steps, okay? Just don't write down the answer because you'll lose a bunch of marks. Got to show all your steps when you do these. Some of them take more steps than others, but do it methodically, step by step like we did on the board, and you'll be fine. But you have to show those steps. Okay, once everyone has written the quiz, we'll go through it together, but I still have a few people left to write it, so we got to wait for that to happen before we can go through it. Okay?